Hi guys, I know this is a bit of a kludge, so I'll try and explain what we've got here. It's a 24 volt relay. I'll just have to grab a little pointer here. Fingers are too fat. Okay, so we have a 24 volt relay right here, and that's a double pole, double throw. Got an LED. Got a current limiting resistor for the LED right here. Okay. Now, the circuit configuration is the same as I've already shown you in the schematic. The only difference is that I'm using the relay for the switch, and I've only got one coil. In this case, it's just a solenoid that can drive off of this. So, real quick, the top rail up here is 24 volts coming right off of here, off the red wire. The bottom rail down here is ground. Those are being driven off of these two batteries in series. I've got a car battery up here, and I've got a little Yuasa or whatever it is here in series. So I got roughly 24 volts. At least that energizes this relay. I'm off of the normally open contact, so at rest, nothing's happening. Let's see, can you see the jumpers down here? We've got a jumper here for the coil on the relay to energize it, and we have a jumper here to provide ground to the common contact. Okay? The other side of that common contact goes to this diode, which has the cathode facing the relay. And that's also where I've got the scope probe for the back EMF pickup. The other side, the anode side, that is where I've got the return for our solenoid. Okay? So that's the return for the solenoid. We have the anode of the LED going to the cathode of that diode. So it's just like the schematic shows, only this LED is replacing the back EMF diode that feeds the battery to the B+. The cathode side of that diode goes to the limiting resistor, and the other side of the limiting resistor goes straight to B+. Okay? So the only time that this LED can conduct or turn on is when both of these contacts are open. And the only thing that can light it up is the back EMF, moving from the open coil over here, which is isolated now. Say, it's on the normally open contacts, so any energy that's stored in there is isolated, and the only place it can go is back to B+. Okay? Now over here, I have a couple wires. One comes from the 24 volts. It goes out to this switch. Let's see if I can get it in the picture here. Goes out to this reed switch. Okay? And the other side goes to the relay coil. So we're going to use this single reed switch to drive that coil. Okay? And I thought that it would be appropriate if we use the old whip bag chassis to do that. And so when that comes in contact, or comes in proximity, we get the clicky-click there, and it energizes contact, okay? So, let's spin this puppy up, shall we? And take a look at what the scope shows. Okay, so there's that, and there's our scope. The top trace is our back EMF going to the ground terminal. The bottom trace is the other side of the solenoid coil. And looks like I'm getting a little bit of interaction between the cell phone camera and the scope redraws. It seems to be going out on the picture, but it's not going out on the actual scope. So, that's the back EMF pulse, that positive going pulse. Now what I didn't show is where my reference is for the scope. It's coming right off that negative rail there. If you can see right there, that's plugged into the negative rail. I got both scope probe references right there. This is just a dead end, using it for a contact point. So that's where we get the earth ground, because my scope is grounded to earth. That provides an electron source for the batteries. Okay. Now, question is the LED lighting up? Because the only time that LED could light is when the switches are open. Well, let's find out. Well, the answer is yes, it is. The LED does light. The back EMF does flow from the open coil, which is completely isolated, our Gilligan's Island, through the LED back to the B+ terminal. Okay? So, I hope that answers the question sufficiently. I'll get this posted up for you guys, and then we can discuss it, okay? Catch you later.